It's happened to you, standing in a room you've never set foot in before, having a conversation you've never had, and somewhere underneath all of it, a quiet, certain voice telling you, you've done this exact moment before. Same words, same light, same feeling in your chest. You know it's impossible. You just walked in. And yet, the certainty doesn't fade. It sits there for a few seconds, completely convinced, before vanishing as fast as it arrived. You call it déjà vu and move on with your day. But you've never actually asked what just happened inside your skull. And the real answer isn't spooky at all. It's something closer to a glitch report. Except the glitch isn't the problem. It's proof something in your brain is working exactly the way it's supposed to. For most of history, there was no good explanation, so people invented one. Some cultures called it a fragment of a past life leaking through. Others treated it as a glimpse of fate, a sign you were exactly where you were always meant to be. In the last few decades, pop culture gave it an even stranger spin. The idea that déjà vu is a literal glitch in the fabric of reality, a stutter in the simulation we're all supposedly living inside. None of these explanations have any scientific backing, but they all share one assumption, that déjà vu means something is malfunctioning. That assumption turns out to be backwards. Here's what we actually know about who gets it. Somewhere between 60 and 80% of people report experiencing déjà vu at least once in their life. It peaks hardest between the ages of 15 and 25, then steadily declines as people get older. It happens more often when you're tired, when you're stressed, and, strangely, when you're traveling somewhere new. None of that sounds like a glitch in the universe. It sounds like a pattern tied to something measurable in the brain. And the first real clue about what that something was came from one of the strangest medical discoveries of the 20th century. In the 1950s, Canadian neurosurgeon Wilder Penfield was operating on patients with severe epilepsy, performing surgery while they were awake so he could map their brains in real time. He'd touch an electrode to different regions of exposed brain tissue and ask the patient what they felt. When he reached a region deep in the temporal lobe, something remarkable kept happening. Patients would suddenly insist they'd lived this exact moment before. The operating room, the voices, the lights, all of it. Penfield could trigger déjà vu on command, like flipping a switch just by touching the right patch of tissue. That discovery linked déjà vu directly to the temporal lobe and to a structure inside it called the rhinal cortex, which sits right next to the hippocampus and plays a major role in deciding whether something feels familiar. It also explains something doctors had quietly noticed for decades. People with temporal lobe epilepsy often experience intense, repeated déjà vu in the seconds right before a seizure begins, like an early warning flare going off in the brain's memory-checking circuitry. For a long time, that was where the science stopped. Déjà vu looked like a memory system briefly misfiring, sending a false signal of familiarity for no good reason. But that's only half the story. Because misfiring doesn't explain something crucial. Why the feeling always corrects itself almost instantly. You don't actually believe you've lived that exact moment before. Some part of you knows immediately and with total confidence that the feeling is false. That correction is what modern researchers started paying attention to. There was still a missing piece, though. Penfield's electrode could trigger déjà vu in a surgical patient, but it couldn't explain why it happens to ordinary people, in ordinary rooms, with no electrode anywhere near their skull. That question fell to psychologist Alan Brown at Southern Methodist University, who spent years collecting and analyzing thousands of real-world déjà vu reports. He noticed something almost everyone overlooked. People rarely get déjà vu in completely unfamiliar places. They get it in places that share a hidden structural resemblance to somewhere they've actually been. The same furniture arrangement, the same door-to-window layout, the same general shape of a room, even if the specific location is brand new. Brown called it the Gestalt familiarity hypothesis. Your brain doesn't need to recognize a place outright to flag it as familiar. It just needs to recognize the underlying spatial pattern, even while the conscious recollecting part of your mind has no idea why. That's also why déjà vu spikes when you're traveling. New cities are full of spaces your brain has never consciously catalogued, but that quietly echo thousands of rooms, streets, and layouts it has filed away without you ever noticing. In 2016, cognitive neuroscientist Akira O'Connor at the University of St. Andrews designed an experiment to trigger something close to déjà vu inside an MRI scanner. He had volunteers study lists of closely related words: bed, pillow, yawn, snore, dream, without ever showing them the one obvious word tying them together: sleep. Later, he'd ask whether the word sleep had appeared on the list. It hadn't. But because the brain had been primed with so many related concepts, a striking number of volunteers reported a strong, eerie sense that it had: a manufactured taste of déjà vu, built in a lab on command. Here's where it got interesting. O'Connor expected to see activity in the hippocampus, the brain's main memory retrieval hub, since that's where you'd expect a false memory to be generated. Instead, the brain scans lit up somewhere completely different: the frontal cortex, the region responsible for decision-making, monitoring, and resolving conflicting information. The hippocampus, the part that would have generated a false memory, stayed quiet. The frontal lobes, the part that checks memories for accuracy, were working overtime. That detail flips the entire story. Déjà vu isn't your hippocampus accidentally generating a false memory. It's your frontal lobes catching a false familiarity signal somewhere in the system and actively flagging it as wrong in real time before it can fool you. Déjà vu isn't the malfunction. Déjà vu is the fix. That reframing explains the age pattern too. The frontal lobes, the part of the brain running this error-checking process, mature relatively late and start gradually declining function earliest of any brain region as people age. Teenagers and young adults, right at the developmental peak of frontal lobe efficiency, get hit with déjà vu the most, not because their memory is faultier, but because their internal fact-checker is working at full strength, catching more false familiarity glitches and flagging every single one. Older adults experience fewer episodes of déjà vu not because their memories are cleaner, but because the system policing those memories has quietly started to slow down. The feeling you've spent your whole life treating as eerie and meaningless might actually be the clearest evidence you'll ever get that your brain's quality control system is doing its job. Which means every time it happens to you, what you're feeling isn't a crack in reality. It's the opposite. It's your brain's memory system throwing out thousands of pattern matches per second, scanning every room, every conversation, every face for the faintest overlap with something you've experienced before. And once in a while, by pure statistical coincidence, two unrelated moments brush close enough together that the system briefly flags a false match. Then, almost instantly, a separate part of your brain steps in, checks the math, and tells you, false alarm, this is new. You only ever notice the half-second between the alarm and the correction. You never notice the correction happening successfully thousands of other times a day, silently, without ever rising into your awareness at all. So the next time it happens, standing somewhere new, certain for one impossible second that you've lived this exact moment before, you're not glimpsing a past life, and you're not catching a glitch in the simulation. You're watching two ancient separate systems in your skull disagree with each other for half a second, and then quietly resolve it correctly before you even have time to be afraid. It isn't proof that something is wrong with you. It's proof that every single day, in ways you'll never consciously witness, your brain catches its own mistakes before they ever become yours. Think about what that actually requires. Somewhere behind your eyes, a system is constantly comparing the room you're standing in right now against every layout, every conversation fragment, every half-remembered detail you've ever filed away, running that comparison continuously, silently, for every waking moment of your life. Almost all of the time, it gets the answer right without you ever knowing the check happened at all. Déjà vu is simply the one time in 10,000 where the comparison comes back ambiguous enough to surface into your awareness. And even then, a second system is already standing by to correct it. You spend your whole life walking around inside a near-perfect surveillance system built entirely out of memory, and the only proof you'll ever get that it's running is the rare half-second it briefly, harmlessly gets it wrong.